Welcome back, mathematicians. So for this lesson, it's going to be on simplifying algebraic expressions, and you're going to need two different colors as well as a pencil, and I'm going to be using a black pen because it shows up better on camera. So first I want to go over a definition on like terms. We briefly talked about this earlier when we were adding and subtracting terms. We can only do that when we have like terms. And those are terms that have the same variable. So for example, 2x and 1/2 x, both just have x as a variable. And x squared, 3x squared, those both just have x squared as a variable. So our goal here is to simplify algebraic expressions. And when we simplify algebraic expressions, so I want that in a color, I did green, we add, subtract, multiply, or divide all of the different like terms separately. Okay, so when we come up with an answer in math, it can be a complicated equation or a complicated expression, and we want to make that expression shorter for the reader. It's almost like you don't want to give somebody an unfinished or a half-done project, right? Because they would then have to finish it. So what we want to do is we want to simplify our answer so there's nothing else that the reader has to do or has to look for to find the finished product. So that's what we're going to do here. We're going to simplify these three expressions. And the way we do that is we add the coefficients of the like terms. For our first example, we have 1.2p plus 0.1p plus 0.5p minus 7. So if you're a visual learner like I am, what I did is I color-coded all of the variables separately. So this one had the variable p, this one had a variable p, this one has the variable p. They're all the same variable, so I used the same color, which was blue. And this 7 does not have a variable with it, so it's not like the others. Okay. Now, when I simplify this, I want to combine all of these like terms. And the way I do that is by using my skills from the previous two lessons with addition and subtraction. Now, what I like to do is I like to group them, not necessarily by rearranging them if I don't have to, but by circling or squaring, or sometimes having to use a triangle if we have a bunch of different like terms. So let's circle and square for this one. Here I have 1.2p, okay, and that's a positive 1.2p. Here I have 0.1p, and this is a addition symbol, so we know that that's also a positive 0.1p. And then I have 0.5p, which is a positive 0.5p. And then I've got a 7. The 7 does not have the variable p, so I'm not going to circle it in blue. What I'm going to do is I'm going to square it just to show that it's different, it's not the same. And now I'm going to simplify by adding the coefficients of the like terms. So over to the left here, I'm going to do 1.2 plus positive 0.1 plus the positive 0.5. And when I add those up, 2 plus 1 is 3, plus 5 is 8. Carry down the decimal. And 1 plus 0 is 1. So now these like terms have combined to be 1.8p. And I'm subtracting 7. There's nothing else to combine with the 7, so that is the simplest form that the expression can take. So that's my final answer. For example 2, we've got 1/2 x minus 1/4 x plus 5 minus 2. So again, we're going to circle and square our like terms together. So here I have 1/2 x, and I'm taking away 1/4 x. So 1/2 x, and I'm subtracting 1/4 x. And then I have, right, and these are both positive, positive. Then I have a positive 5, I'm adding 5. And I am subtracting 2. Right, those are both like terms because they don't have a variable. And now let's combine these together. So I have 1/2, and I'm taking away 1/4. So over to the side here, I'm going to combine these two variables by adding or subtracting their coefficients. In this case, I'm subtracting. So I've got 1/2 minus 1/4. And I need a common denominator for those fractions. So you think of the least common multiple. So for 2, it's 2, 4, 6, 8, 10, right? For 4, it's 4, 8, 12, 16. So the least they have in common is 4. So that's already in 4s, so I can leave that as 1/4. And 1/2, in order to get to 1/4, I would have to multiply the top and the bottom by 2. So that gives me 2/4 minus 1/4, which is then just 2 minus 1, or 1/4. So I've combined these two to be 1/4 x. And now I'm combining these. I've got a positive 5, and I'm subtracting 2. 5 minus 2 is 3. So when I bring these down, well, let's draw the arrows so they're a little bit together. When I bring these down, 5 minus 2 is 3, so that's plus 3. And that's my final answer for example 2. For example 3, we've got 5x plus 2y minus 7x plus 4y. So let me show you a different strategy, and one that I think is more useful than I used in part A and part B. So I'm going to use it now for part C. When you are circling and squaring and grouping your terms together, a good idea is to take the sign or the operation that's to the left of that term. So for example, my like terms here, I have 5x plus 2y minus 7x plus 4y. And my like terms are going to be this 5x here. That doesn't have an operation symbol to the left of it because it's the first one we see. And then I have this minus 7x. So I'm actually going to take that operation with me. And I'll show you why when we start to combine those together. Okay? Now I've got a 2y and a 4y. In green, because it's a different term, right? It's not like the others. I can circle it in a different color. I could square it. I could triangle it. But I want to include this this operation symbol because it shows me what type of number 2 is. Is it positive or is it negative? So here, I'm going to square the 2y. That's more of a rectangle, but I'm going to box it in. Same with the 4y. Okay. Now, what happens when I group them together? I've got 5x minus 7x. It's a bad looking 7. 5x minus 7x. And I've got 2y plus 4y. Okay. And then when I combine these like terms, I'm just going to simply add them together. They're kind of grouped like that. And just like before, when I was subtracting with integers, I'm going to do 5x minus 7x, and I'm going to add the coefficients together. So what you want to think of here is, forget about the x's for a second, because my final answer is going to have an x. What is 5 minus 7? So off to the side here, if I do 5 minus 7, and I do keep, change, I've got 5 plus negative 7. And when I think about integer chips, or I think about a number line, I start with 5 positives and I add 7 negatives. So I'm either counting 7 jumps to the left, or I'm putting down 7 negative chips. Either way, with chips, some are going to cancel out and you're going to be left with -2. Or when you jump 7 jumps from 5, you're going to get to -2. So right here, 5 plus -7 is -2. So our answer for that group is -2x. This one's a little bit simpler. 2y plus 4y. We know we're going to have a y at the end. And we're just doing 2 plus 4. Probably don't need to write this part in your notes, but just so you have it, 2 plus 4 is 6. And then you have 6y. And so you're adding 6y. So my final answer here is -2x plus 6y. And that should be as complicated as these problems get. Sometimes it's a combination of B and C. So if you look at the problems I want you to do in your book or your notebook here, you're going to simplify 1.5t plus 4t plus 3. Next is 1.8m minus 0.9m plus 2. The third is 3/7 x plus 3/5 minus 2/7 x minus 2/5. And lastly, 6a plus 9b plus a plus b. And what I want you to do is I want you to use this strategy on part C here, where you circle or square, and when you do that, you combine inside of that circle or that square the operation symbol. And if you know you've done it correctly if you don't see any gaps. So see how this goes from a circle right to a rectangle, right to a circle, right to a rectangle. So there's no gaps. I've combined everything together, and I think this is probably the best way for you to do it until you start being able to do it in your head. So you're going to do these 4 problems. You're going to show your teacher. They're going to check them to make sure you're ready to move on, and then you'll do the practice problems in the textbook.